Part was talking about classifying triangles. We had ways to classify the triangles by the angles and by the sides, right? How did I classify by the angles? No, not necessarily. Well, kind of, but what did we do yesterday? What were the two things on the bottom of the quiz? What? Yeah, well, how do isosceles, which meant what? Two sides were congruent. What else? Equilateral, which meant all the sides. And then what was the other one? Scaly meant none of the sides. Okay? How about by the angles? Right? Acute and obtuse. Every single triangle has two acute angles, and then we identify it by that third angle. All three of my angles always have to add up to what? 180 degrees. So keep that in the back of your mind for everything that we're going to do today. Okay? So in number 11, how could we describe by the angle ADB? Obtuse because of 120. Number 12, BCD. Because of my box, right? And then 13 is ABC. ABC. Right again, right? Because we go back to that same box. Okay, so they're kind of trying to lure you into a different thought process. Number 14. How can I find X? Exactly right, because that triangle would realistically be a what? Isosceles triangle. Here's the other thing that a lot of people tried yesterday. Okay, something like this. They said that 2x minus 6 is equal to 60. A side and an angle can never be equal to each other. Remember I said they kind of go together, but that just means that if this is the smallest angle, this has to be the smallest side, and so on and so forth. But they're never going to be equal to each other. That makes sense? Know what I'm saying there? So yeah, you're right that they go together, but it's just for the relationship between the angle and the side, not that they're actually congruent to each other. Okay? Okay with that? And again, I know it's not as complicated as some of the things that I come up with, but you just kind of got to live with it. 17, 18, 19. Find the measure of each angled pair. So now we bring in things from the past, like vertical angles, linear pairs. We could use alternate interior angles, but we can only use that if what? I have parallel lines, okay? And how do I know that I have parallel lines again? The little arrows, perfect. Okay, so how can I find 1, 2, and 3 in this, and what would probably be the easiest one to find? Number 1, right? Because what? Perfect, add them up and subtract it from 180. So 70 and 30 is 100, so we get 110, so what's 1? 70. So what's my next one easiest to find?
2.
Probably 2. Okay, because why? It's a linear pair, so we're going to take 70 and do what with it? Subtract it from 180. Okay, so how the heck do we find 3? Okay, 2, the blank spot, right? So you could use vertical angles. Any other way that you remember? Con?
You can do like exterior angle thing.
Yeah, the exterior angle thing, right? So we figured out that angle 2 was 110. Remember, the exterior angle is equal to the sum of the two remote interior angles. So we would have had 2 plus, what was the other one? Plus 28. So you could have done it that way, but it totally works the way Kenzie said it too. Do your vertical angles and then subtract it from 180 like America did the first one. Make sense? Okay. As we're in that section right now, flip over to page 315. Got another kind of example of this kind. In 4 through 7. So if I looked at this process and they just kind of told me to find all of them, where would you start? What's the easiest one for you to find in this one? Maybe angle 1, because why again? Linear pair. What else would be really easy? 4, because vertical angles, perfect. So then if I found 4, then I can find 2 by adding and subtracting, right? Bless you. And if I find 1, then I can add and subtract to find 3. Or we could do what Con said, right? My exterior angle 125 is equal to angle 3 plus 62. Everybody agree? All right, flip back. So we want to now look at 4.3. So we talked about congruent triangles. That was kind of the big old plot of the whole chapter, right? What were my 4 ways to name triangles congruent? SAS, SSS, AAS, ASA. And again, that's where you're talking about the angles and the sides in my 2 congruent triangles that are corresponding spots. And again, this is what still kind of confuses Ms. Hine. How do I know that? I just go in order and read what I have. So if it's an arc and then a slash and then an arc, I have angle, side, angle. But you got to read them in order. Okay? So in number 21, would you say that angle 21 is congruent? Would you say that quadrilateral is congruent, the first one to the second one? Remember, if it's congruent, it has to have all the angles and all the sides congruent. Thomas says yes. So again now, when you talk about this and they ask you to write a congruent statement, that's saying the first quadrilateral is congruent to the second quadrilateral, and you need to put the letters in order. So what would you write for number 21? Angle B or D, you said, is congruent to J? Exactly right. What else? And how do you know all that? Okay, so is A and H the same thing? No, right? A would go with what? F. They can try to mess you up, right? So remember, my congruent statement would be, and in this one you just write quad or whatever. The first one I don't care, right? I just have to write the letters. And then I would say is congruent to quad, and now is when I have to be careful, right? So if I said A, B, C, D, I have to say what? F, G, H, J, did you say? Okay. And everybody understand why? Because of those arcs, like Merrick was saying. Okay? So, in number 22, are those 2 triangles congruent? And if so, what is my congruent statement? Would you say they're congruent? And realistically, why would we say that? Which one of those 4 things would this meet? Side angle side, right? Because we have 2 arc or 2 slashes, and then the 61 in between the 1 slash. So, again, think about your congruent statement. The first one, it doesn't matter, right? We could say XYZ, we could say ZXY. It doesn't matter. But then when we get to the next one, we just got to make sure that it pairs up. So what has to go with Y? K, right? And what has to go with Z? L. So just when you write that out, make sure those corresponding letters or in the same spot. Bless you. Okay? Number 26. Could I prove that those two triangles are congruent by one of those four methods? Which one? Yeah, it would be side, angle, side. And why do you know that?
Because the arc and the lines in the box.
Okay, and then where do I get my second slash? To make side, angle, side. That what? Yeah, the middle line, right? And we know that middle line is congruent to itself because why? Reflexive property. Awesome. How about the 27? Do I know that those two triangles are congruent? Trick question, right? So a lot of people say yes because they look at it and they just see a bunch of slashes. But the two slashes are on the same triangle, right? I need the two slashes to be on one and then the other. So it's not, right? So there's no way that I could say that those are congruent. Any questions there? We'll come back and try to do 29 and 30 as proofs. Let's get through the rest of it and then we can come back. Number 31. Can I figure out what x is in 31? Because why? They're congruent, right? Because it's an equilateral triangle or equal angular triangle. So how do I find x? Set them equal to each other. Does it matter which ones? Not in this one, right? So realistically, I'm going to avoid the fraction. I'm going to use 7x minus 7 is equal to 5x minus 1. Need to see the math? Again, the biggest thing for still some of you is answering the question for what it is asked. This one, I don't know what it said. Find the value of each variable. So you're just finding x. But if it says find x and the angles, then you have to do the work of finding and putting it back in. Now again, you wouldn't care which one you put it into because they're all the same. How about 32? Can I find this one? Wow.
Because since the sides are here, the angle is not able to be 52. And then you just add them together and subtract.
Everybody agree with what Bo said? So this is an isosceles triangle, and I know that because my 12s are on the sides. And so if the sides both have 12, the angles opposite of that have to be the same thing. So if one was 52, the other one was 52. Exactly right. You want to see the math? Turn the page. I want to look at 18 and 19 on the other page, page 315. Can I find angle 1 in this figure? What is angle 1? 66 because my triangle is a what? An isosceles triangle. Can I find angle 2? How am I going to find angle 2?
You find 3 and 4.
Okay, so I can find 3 because of what we just talked about, that it being isosceles. And then I could do the 4 because it's a linear pair, or I go back to what Con said at the beginning, right? If I find out what angle 3 is, angle 3 has to be equal to 24 plus angle 2 because of his exterior angle theorem again. Okay? Any questions there? So that's kind of the math part of it. Now, the fun part, right? Let's go back to page 313 and do some proofs. So again, if you want to try these on your own, you want to leave these for over the weekend because they're in the book, and then I can do other ones that I have right now. So we got a couple to go back to. So those two are relatively, not too bad. So here's my figure. Now again, don't get frustrated, you guys are getting a lot better at this. And I think you will even admit that. It's just, some of the things are still frustrating for you. So don't get frustrated. So, big given. And let's say approve is angle J, LK is congruent to angle PLM. Alright? So there's one that we can work on here. And get a couple written up here so we can concentrate without stopping all the time. So there's two different ones. So again, in the first one here, when they give me this given, I'm going to go through and I'm going to put each of those things down on my figure, right? So it says angle J is congruent to angle P. And then maybe even I come over here and I cross that out because I know I've already done that. Okay? JK is congruent to PM. And again, I can cross that out. Then they tell me JL is congruent to PL. Okay? And then it tells me that L bisects KM. But if I looked at this right now, what they gave me in the first three portions basically tells me that I already have congruent angles, right? Because I have what? Side angle side. So they kind of went overboard in this one. So basically, I'm going to write down blah, 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 my given. And again, I don't think anybody really missed that. So I hope not. Okay? And then we would say what? Triangle what? JKL is congruent to triangle PML. And that's where you got to be careful, right? Because you want to make sure that they're in order. So again, you're looking at the arcs and stuff. And why can we say that? Side angle side. Awesome. And then the prove, we want to do these two angles, right? So we could say angle JLK is congruent to angle PLM because why? CPCTC, or you could have just said vertical angles, right? You didn't even have to do this step. So that's kind of a weird one. I don't know why they give you so much information. Because they actually give you L bisects them too. So that one was hopefully pretty easy. So let's look at this one then. What? Thanks, buddy. These up here. C. A. Does that help? Yeah. So again, as Ms. Grease said earlier, if I have parallel lines, automatically I should think about what? Alternate interior angles, right? Okay? And this is where, again, I reiterate what I told Ryan earlier. It's got to, my angle, the arc, has to touch the parallel side and the transversal. Okay, so, what do you think? Well, obviously, again, blah, 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 given. You always have that. And then what? CBD, I believe you said, was congruent to what? ADB. Perfect. And again, definition of alternate interior angles. So again, as you say that now, don't forget to actually go up there and do it. So he says CBD. See how we're saying that they are touching the parallel side and the transversal, but they're alternate interior, so they're on opposite sides of that transversal. What else? DD is congruent to BD. Why can we say that? Reflexive, awesome. So let's put 2 there. Now I need one more thing, right? So I gotta have another side or another angle. Right now, because of what we know about quadrilaterals or parallelograms, we don't know anything about the sides with respect to parallel lines. So you, in this situation, going and trying to do the sides, we don't really know that concept yet. We will down the line, but we just don't know it yet. So what's my other option? My other set of alternate interior angles, right? So what would we say? CBB is congruent to angle ABB. Exactly right. Alternate interior angles again. So then come back, and now I'm going to say, right? And so again, make sure that you go in order of what I have in one of the triangles. So I start right down here. I got angle, side, angle. Is that one of my 4 things? Heck yes. So triangle, and again, it doesn't matter how I name the first one. So what do you want to say for the first triangle? ABD is congruent to triangle. So if we start with A, we have to start with C. And what goes with B? B goes with D and then B. Did I say that right? I didn't write. I said it right, but I didn't write it right. And why can we say that again? Angle, side, angle, right? We got 2 sets of angles and 1 side. Is that what we needed? No, we wanted to prove that those 2 angles were congruent, so now we can say that, because if our triangles are congruent, then everything has to be congruent inside those triangles, so we'd say, and you're getting a lot better at CPCTC. So again, you cannot use CPCTC unless you already proved that the triangles were congruent. Okay? How do we do? We want to do another. What was that? Anybody wanna do another? We still got 10 minutes. So again, over the break, or sorry, well, yeah, kind of break, over the weekend, if you wanna do more proofs, those that were in the review are actually two really good ones. And they're really not too bad. Does anybody want to see another one while we're waiting, or we good? Okay, so some of you have corrections to be made on that last quiz. So take the time right now to work on those corrections. You got 10 minutes, so you can get that handed back in before you leave.